Hello, good morning to all of you. Hope you are doing well at this time. So today, what we'll do is we'll start with the software engineering curriculum. We'll start with defining a very simple term that is called a system. Now, if you see, system has uh, two different origin. In context to Latin, system basically refers to um, making an arrangement of things. In case of Greek, system basically refers to creating a collection of components, creating a collection of components that rather compounds to the whole. At this point in time, it may be difficult for you to understand or to interpret the term, but let us try to understand system uh, in its very basic. A system refers to a collection of components that work together to realize certain objectives. Now, to further elaborate on this, a system is a collection of rather related components that work together in order to realize certain purpose specific objective. Now, purpose specific objective basically refers to objective that you want to attain. A system has in it basically three different components. The components, in simplicity, these are called as input unit, the processing unit, and the output unit. Now, as the name says, input unit is a unit that is capable of sensing the environment and communicating the information to the processing unit. That implies input unit is capable of converting physical data that is there in the environment to logical data that can be interpreted by the system. Likewise, the processing unit processes the sensed information and generates certain valuable information further as per the set of well-defined instructions that are placed in it. That implies processing unit transforms logical data in one form to logical data in another form. And subsequently, the output unit is a unit that is capable of communicating the processed information back to the environment. So these three units have their own specific role to play. Now, to understand system further, a system can be understood in correlation with some other physical or a logical system. So, for an example, a human body is the best example for a system. Although it's a physical system, but it's a best example for a system. Now, if you see and closely analyze a human body has three different types of units. A human body has an input unit that senses the environment. So, for an example, your hand, your eyes, your nose, your ears. These are units that are capable of communicating the information from the environment to the central nervous system to the brain. So the brain is the processing unit. The brain processes the sensed information as per the set of instructions that are inbuilt in it and generates certain valuable information further, which is communicated further to the environment using the output unit. So this is how a system basically works. Now, why do we need a system? There might be a question that might be triggering your mind. Why do we need a system when we can solve a problem? Now, systems are created to solve problems. Systems are created to solve problems that a human being cannot. It may be very easy for us to add a two-digit number, but it may be difficult for us to add a two 1 lakh digit number. So at that point in time, system comes in handy. Now to elaborate on system further, system is a set of interacting or independent entity forming an integrated whole. Now just see this particular definition has in it various components that needs to be um, briefed upon. So system is a set of interacting entities. Yes, a system is a collection of interacting entities. Entities that are guided by certain relationships and axioms or meanings. So a system is a set of interacting entities. Now, independent as well, because system should be built in a manner that a system exhibits a very high degree of reusability. That implies that a component from a system can be picked in any point in time in future and placed in a new system and make it realize certain objective. So yes, a system is a set of interacting entity that should be rather organized as independent entities. And collectively it's capable of realizing certain business is what integrated whole basically tries to imply. So a system is a set of interacting entities that are guided by certain relationships and meanings, which should be organized rather independently, forming an integrated whole because it should be capable of realizing certain objectives. Now, system has in it certain characteristics that guides the structure of the system. So the most important characteristics of a system is that a system should have or should be governed by certain well-defined structures. Structure that is governed by its part and its composition. Now you must have heard in the past that there are different types of structure that can be provided to a system. For an example, you may have a function-oriented system, or you may have an object-oriented system, or you may have a service-oriented system. So in case of function-oriented system, the structure is guided by function and the data flow in between them. In object-oriented system, the structure is guided by object and their relationships. In service-oriented system, the structure is guided by the services and the relationships that exist between them. So any system that you want to build should have certain definite structure that governs the integrity of the system. Now, once a system is provided a suitable structure, it should be capable of exhibiting certain behavior. As we have already discussed previously, a system should be capable of exhibiting certain behavior, like a system should be capable of taking in input, system should be capable of processing the input, and should be capable of generating some valuable information as per the set of well-defined instructions that are inbuilt in it, and it should be capable of sending the valuable information back to the environment. So a system should be capable of exhibiting behavior in terms of taking in input, processing it, and generating certain output. Now the third and the most important behavior a system characteristics a system should have is that systems should have interconnectivity. Interconnectivity between the various components that are there placed in the system. Because as we have already said, that system is a collection of related entities which are collaboratively capable of realizing certain business. So in order to facilitate collaboration, it is very important for us to maintain interconnectivity. So these are the three important characteristics that a system should exhibit. It should have a well-defined structure. It should be capable of exhibiting behavior, and it should have interconnectivity between various components. Now, what you must be wondering what may be the objective of going through this lesson. The basic objectives of going through this lesson is to make you understand what is a system, to make you understand the various different phases that system development life cycle has in it. Please don't get confused. I'll elaborate on it. And then to know the components system analysis and to know the components of system design. So these are the four different objectives. These are the four different objectives of this particular lesson to make you understand what a system is, to make you understand the different phases of system development life cycle, and to make you understand different components of analysis and design. Now we'll come to system analysis and system design later, at later point in time. We'll be going through it in sequence. Okay. So to start with, system life cycle. Now, system life cycle basically refers to. Please listen to me carefully. It basically refers to a series of identifiable phases that a system goes through during its lifetime. I'll repeat it. It's a series of identifiable phases that system goes through its lifetime. Now, there are different phases that a system goes through during its lifetime. But in order to complete it, you need to also include that from where to where. So, system life cycle is a series of identifiable phases that a system goes through its lifetime, right from conception to retirement. Now, conception is a point in time when the problem strikes the mind of the customer, whereas retirement is a point in time when the system will be no further put to use. So, between conception and retirement, whatever phases that soft system goes through is called a system life cycle. Now, system life cycle can be broadly partitioned into two different phases. One is called as the development phase, and the other one is called as the maintenance phase. In development phase, the system is developed, whereas in case of maintenance phase, post-delivery alterations are introduced to the system. Now, in both the phases, may it be developing phase or may it be maintenance phase, development is done in both the phases. But development phase is a phase that refers to a phase that is prior to delivery, whereas maintenance is a phase that is referred to post-delivery phase. So during the development phase, a system goes through several identifiable phases. Right. To start with, the first phase in development phase is the study phase. Study phase. There then comes a feasibility study phase. Then comes requirement analysis and specification phase. Then comes planning phase. Then comes design phase. Then we have coding phase. Then we have deployment phase. And onwards we have maintenance phase. So in case of development phase or developing phase, you have series of phases. I'll repeat it. You have initial study phase, you have feasibility study phase, you have requirement analysis and specification phase, you have planning phase, you have design phase, you have coding phase, and then as a part of development we have the implementation testing phase, and then as part of development we have implementation phase as well, and then subsequently we have the maintenance phase. So now to start to elaborate on the various phases further, the first phase that we have in development phase is called a system study. Now here the basic objective of the system study phase is to know what is the scope of the system. The scope of the system, what I imply by that is the the extent to which the system goes in order to provide solution for the problem. So system study phase further has two sub phases in it. Uh, there are two sub phases in it. The first phase is called as initial study phase, and the second one is called as detailed study phase. The initial study phase is dedicated for identifying the scope of the existing system, whereas the detailed study phase is is executed in order to identify what additional requirements that the customer has and what are the limitations and the problems that are there in the existing phase. So just see, the objective of two different phases are distinct. In the study phase, you have two different phases. One is called as the initial study phase, and the second one is called as detailed study phase. In the initial study phase, you try to determine the scope of the system, and in case of detailed study phase, you try to determine what are the new requirements of the customer and what are the limitations that the existing system has. So now, once you execute the study phase, a clean proposal is prepared that will highlight whatever findings that you have made. Whatever findings that you have made and whatever recommendations that you propose in order to overcome the limitations and problems that exist in the, the, the current system. So you need to make a neat proposal that tries to identify that tries to highlight the scope of the system, and it also tries to highlight the limitations and the future scope. Right. So to describe it in brief, in case of system study phase, so what you try to do is you try to identify the problem and you try to initiate the project. You try to do a background analysis for identifying the capabilities of the system. And then what you try to do is you try to draw certain inferences or findings and place before the customer with certain refinement. Now, once the study phase is executed, where the scope of the system is defined, the requirement of the customers are identified, the limitations are identified, and proposal in terms of refinement is made, then what we do is we execute the feasibility study phase. Now, the basic objective of feasibility study phase is to determine one's ability in developing the system. Now, once the problem is defined in terms of its scope, now you need to determine whether you are capable of developing the system or not. Or what does it imply is that it implies that whether you have the adequate assistance for developing the system. Now that is the reason why we execute feasibility study phase. Feasibility study phase is executed in order to determine one's ability of developing the system. Now feasibility can be perceived from two different perspectives. One is from the perspective of knowledge and one is from the perspective of economic support. Say for an example, if we have adequate infrastructure for developing the system, but if we do not have the knowledge, then the project is economically feasible, but it's not technically feasible. Whereas if we have adequate knowledge for developing the system, but if we do not have the required infrastructure, then the system is technically feasible, but not economically. So whenever you're trying to determine whether the system is feasible by you or not, you need to look at it from two different perspectives. One is from the perspective of knowledge and one is from the perspective of economic sustainability. So it should be both technically as well as economically feasible. So these are the two types of feasibility that is determined. Now, once you determine that system is feasible by you, we'll elaborate because we have a separate chapter for this. So once you determine the software system is economically and technically feasible, then what we can do is we can move ahead. We can move ahead with the other phases in the system life cycle. So now the next phase that you have is system analysis. Now, system analysis, it may be sounding a bit difficult for you to understand or interpret, but let's try to understand it in a very simple manner. Now, analysis is a term that is used in order to determine 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 whether an entity of interest has certain problem in it, or the capabilities of the entity. So whenever we analyze, what we tend to do is we tend to do that. So in case of a system analysis, what we try to do is we try to identify all possible entities that are there interacting with the interacting in order to realize business. We try to identify the characteristics of the entities. We try to identify the behaviors that are exhibited by the entities. We try to identify the relationship between entities. Now, just see what I'll repeat it. Whenever we try to analyze, what we try to do is we try to identify the participating entities. We try to identify their characteristics. We try to identify their behavior, and we try to identify the relationship that the entities have in between them. So, in order to identify the entities, there are several activities that are being performed. The activities, say for an example, that in order to identify, you interview the customers, right? Again, you interview the customer, or you go for an on-site observation, or you build up a questionnaire, right? To identify various entities that are participating in the system. And when you try to identify the entities, what we try to do is we also try to identify the characteristics or the properties of the entities. In addition, we try to identify the behaviors and subsequently the relationship, right? Again, but whenever you're trying to analyze a system that's to be built, you need to always keep in mind two important things, right? Again, you need to always keep in mind that you are trying to find the facts, keeping the problem in view, because we are interested in identifying only the entities that are participating in realizing the problem, right? Again, and what are the new requirements that the customer has, or customer expects the entities to exhibit. This is very much important. And we should also keep in mind that we should be capable of identifying the pros and cons of the system that we are going to build. So these are very much important. So whenever we analyze a system, these are the activities that we perform. We try to identify the entities, their characteristics, their behavior, their relationship, right? Again, with the aid of the tool like interviewing, or on-site observation, or questionnaires, so on and so forth, right? Again, but you need to always keep in mind that it should be within the purview of the problem. Now, once the entities have been identified, their characteristics, their behavior, and their relationship, what we tend to do is we tend to provide shape to the system. Now, design is a mechanism for providing shape to a system. Okay, shape to a system basically means providing a suitable structure to the system. Okay, now system design is executed over two different phases. Okay, it's called as high level design or architectural design, and low level design or detailed design. In case of high level design, what we tend to do is uh, we tend to adapt a suitable architecture for a system in terms of either function oriented architecture, or object oriented architecture, or service oriented architecture. Whereas in case of low level design, we try to confirm on the data structure and the algorithm that we're supposed to use. I'll repeat it. In case of high level design or architectural design, we try to adhere to either of the architectures, like function oriented architecture, object oriented architecture, or system oriented service oriented architecture. And in context to low level design, we try to conform to a suitable algorithm and appropriate data structure for realizing the behaviors and the relationship between entities. So these are the activities in a very in a nutshell that is performed during system analysis and system design. Now you can use the aid of various tools that are there for design. That, like for an example, flowchart, data flow diagram, data dictionary, structured, decision table, and decision tree, and so on and so forth. There are many tools that are there. Now, once a system is closely analyzed and appropriate design structure is defined for a system, then what we tend to do is we tend to translate that particular design into compute understandable code. Now, coding is a phase where we try to translate the design into a set of instructions using a suitable programming language. Now, it is always advised that the selection of the programming platform should adhere to the architecture that is selected. For an example, an object-oriented language should be used for an object-oriented design, whereas a function-oriented language should be used for function-oriented design, or a service-oriented platform should be used for service-oriented design, and so on and so forth. So, coding is a phase where we try to translate the design into a set of executable, adhering to certain coding guidelines and coding standards. Why do we need to adhere to certain guidelines and coding standard? Is because we should code a system in a manner that it exhibits uniformity or it elevates uniformity so that everyone can understand. So that is what is done in coding phase. Now comes the most important phase, that is called as testing phase. Now, during testing phase, what we try to do is we try to confirm whether the requirements that we had analyzed and specified are met by the system or not. So it is basically used to affirm that the requirements are actually met by the system. Uh, so testing is executed over three different phases. These are called as unit testing, integration testing, and system testing. Unit testing basically refers to testing a module in isolation. Isolation basically means keeping aside the module that has been implemented. What we try to do is we try to see whether the module is capable of realizing the business or not. But in reality, a suitable test environment is to be created, because you cannot only test the module on its own. So what we need is we need the assistance of other modules that is required by the module under test to perform activity. So we need to create a suitable test environment where we have a module that is capable of invoking the module under test, a module that is capable of realizing business for the module under test, and all the non-local data structure that the module requires. So we need to create a suitable a test environment where we have a module that invokes the current module under test. Now these are called as drivers, okay, and a module that is invoked by the current module under test, that is called a stub, and the non-local data structures that the module requires. So the non-local data structure is the responsibility of the driver. So a suitable test environment is to be created in order to unit test a module that has driver, non-local data structure, and a stub. Now once the module has been unit tested, that means once the integrity of the module has been affirmed to or confirmed, then what we do is we go for integration testing. Now, integration testing is a testing phase that is executed to determine whether the modules are capable of collaboratively realizing certain business. Collaboratively realizing certain business means they should perform what they are expected to, and they should be capable of realizing the behavior jointly with the other modules as well. So it's also called as interface testing, and the ability of a module to interface with another module. So unit testing is executed in order to confirm the integrity of the module, whereas integration testing is executed in order to confirm the ability of the modules to interface with each other. Now then comes system testing. Testing is the testing that is eventually carried out in order to determine whether the modules are capable of collectively realizing the business or not, right? So it's executed over three subphases. These are called as alpha, beta, and acceptance testing. Alpha testing is a testing that is done of the system by the members of the same organization. So it's an in-house testing. Beta testing is the testing of the system done by the members of friendly organizations. If an example, you must have heard various softwares being released in beta version. So these are the beta version is tested by a set of friendly customer in order to determine the correctness of implementation. And eventually you have acceptance testing that is executed by the actual customer to determine whether the system that they actually want. Right? Now, once the system has been tested properly or thoroughly, or it has gone through unit testing, integration testing, and system testing, then what we move on with is we move on with implementation phase. Now, in context to system engineering or software engineering, implementation does not refer to coding. I'll repeat it. In context to software engineering or system engineering, implementation does not refer to coding. Rather, it refers to the deployment of the system to the client's environment. Because once till now, the system has been developed in the developer's environment, right? To see the suitability of the system of delivering the expected outcome in the client's environment, what we need to do is we need to deploy it. So implementation basically refers to deployment, right? So here, what we tend to do is we tend to teach the customer how to execute the package, how to enter the data, how to process the data, and how to generate result, right? So implementation can be done in a sequential manner or in a parallel manner based on the requirement. Now, after the system has been implemented in the client's environment, then the maintenance phase starts. Now, as I've already said, any change that is introduced to the system post delivery is called as maintenance. Now, maintenance may be called because of various reasons. Maintenance may be called in order to rectify a problem that was not previously identified, or maintenance may be called for increasing the precision or the capabilities of the system, or enhancing the capabilities of the system, or maintenance may be called for porting the system from one environment to another system, or you must have apprehended certain problem and you call for a maintenance, right? So maintenance may be either to um, perfect, or either to correct, or either to adapt, or to prevent. So these are the four reasons why we require maintenance, and likewise these are called as corrective maintenance, perfective maintenance, adaptive maintenance, and preventive maintenance. A corrective maintenance focuses on correcting problems that were not previously encountered, okay, and it's encountered during use. Perfective maintenance tries to call for changes in order to enhance the capabilities of the system. Adaptive maintenance is performed in order to adapt or port the system to a new environment. As preventive maintenance, you must have apprehended something or forecasted something, a problem that may occur in the future point in time, and then you're bringing about a change in the system. So these are the four types of maintenance that you can have. Now, to sum it up, we have various phases organized in a cycle. So you have study phase, you have feasibility study phase, you have analysis phase, you have system design, you have coding, you have testing, you have implementation, maintenance further, and if you are creating versions of the system, again the process repeats. So this is a brief about system life cycle, and the various phases. So thank you for now. We'll meet up in the next class.